Welcome to the chapter, System Integration and Validation. Welcome to the lesson, Refinement and Tuning to Achieve Electric Motor and Battery Specifications. In this lesson, we will cover some tuning aspects to achieve regenerative braking. SimCenter Amazem has the capability to perform advanced analysis to refine different aspects of the electric vehicle design. As shown during this course, early design phase of a vehicle requires basic selection of vehicle parameters. A preliminary analysis of vehicle performance can be carried out to check if the parameter selection is sufficient to ensure proper functioning of the vehicle. Once a preliminary analysis is complete, the vehicle model requires advanced parameter optimization to achieve higher vehicle performance based on the user's needs. While there are numerous vehicle parameters that can be tuned and refined in a vehicle, we will look at only a few to give a basic idea of SimCenter Amazem's capability. Some key areas of modification for tuning of vehicle characteristics include defining driving cycle used for fuel consumption, range estimation based on tuning different constants and variables such as ambient temperature, air density, wind speed, vehicle loading, etc. Tune parameters in designing a high-voltage battery to achieve range targets. Regenerative braking strategies to achieve greater range estimation. Drive cycles are used to calculate a vehicle's energy consumption in order to estimate battery range or fuel consumption. A common methodology used to estimate vehicle range is to run one drive cycle, record the battery consumption, delta in state of charge per kilometer, and linearly extrapolating the distance that could be traveled before minimum state of charge is reached. So, it becomes critical for a vehicle to follow the drive cycle velocity profile closely in order to correctly estimate the range. Certain vehicle parameters should be iterated in order to ensure the control speed is close to the vehicle speed. Along with the battery parameters, simulated driver parameters also need to be iterated to achieve an acceptable tolerance between the control velocity and the actual vehicle speed. A key component of any electric or a hybrid vehicle is the high-voltage battery pack. Selecting an appropriate battery pack is critical in order to meet the range targets along with meeting other vehicle performance targets. Important battery parameters that need to be tuned to achieve optimum battery performance: selection of cell chemistry, thermal requirements of the battery pack depending on the operating environment, sizing of the battery pack including pack design, cell mass, etc. Voltage and energy targets. These parameters can be refined from different tools available from the variables window in SimCenter Amazem. We will specifically look at the battery pre-sizing tool in order to tune the parameters. Regenerative braking in electric or hybrid vehicles is used to convert the kinetic energy generated during vehicle deceleration into electrical energy to recharge the high-voltage batteries and power the electric motor. While SimCenter Amazem is capable of using different strategies to efficiently use regenerative braking, key parameters are used to decide if regen braking will be activated or deactivated during vehicle operation. In our model, regenerative braking parameters are set in the Vehicle Control Unit submodel. Based on the required specific application, the VCU parameters need to be tuned to achieve efficient regeneration during vehicle braking. The VCU is used to command the electric motor to be used as a generator to charge the battery when the brakes are applied by the driver. As part of refinement strategy, users can tune the parameters shown to achieve an efficient regenerative braking performance from the vehicle. Regenerative braking strategy: series, fixed repartition, full parallel and parallel. Torque repartition during regen braking: the amount of braking torque applied on the driving axle when regen braking is activated. Threshold on motor RPM: user can set thresholds on electric motor RPM to define when regen braking can and cannot be used. Threshold on state of charge. User can set thresholds on battery state of charge to define when regen braking can and cannot be used. With this we end our lesson on refinement and tuning to achieve electric motor and battery specifications. Thanks.